Aloha and welcome. In this section, we're going to be talking about lists. We've used lists a little bit in the past, but we're going to do a deep dive in this chapter. So without much further ado, let me share my screen and pull up our handy dandy, lovely VS Code. And here we go. So with lists, we know that they're containers. They group related objects together. They're also what we call a sequence type. It's positioned from left to right in a positional order that you can access via an index. You'll remember we've had other things like this. You think of strings. Strings are a sequence of characters you can access with an index going from left to right as well. So each element can be a different type in your list. And also you can create a list using the list keyword here, a list function. And the list function takes an iterable object as an argument. So over here, we've got car list, and we're saying equals list, empty. So this is going to essentially do nothing for us. So if we, let's clear out our screen down here. If we hit play, we're going to see that it has an empty list. So let's go ahead and make it a little bit more exciting. Let's go ahead and say list of ABC. Now, when I look at this, in my head, I'm thinking, oh, this is going to make a list with one item. However, it's good. We set up here that list takes a single iterable object argument, and it takes that and it breaks that up into several. Well, let's just see. Oh, that's not going to give us what we want right there. So it's taken ABC as the single iterable object and broken it into the sequence of A, B, and C and turned that into a list. So that was a little bit counterintuitive in my opinion, but let's see what we can do here. Now, if you are thinking along the lines that I was just talking, you'd think, oh, wow, we've got a list of things here. This should produce a list of those. So if you're used to JavaScript and something like that, you might get the idea that that would work. But when you hit run there, you're going to find that it expects at most one argument, and it got 3, 1, 2, 3. So that is the hint that we need to make that into a list. So honestly, you're not getting anything extra by putting list here, because when we go and we do this, and you'll see that we get a list of Prius, BMW, and Lexus. But that's essentially the same thing as doing this here without using your list keyword. So if you hit play, you're gonna see you get the exact same thing from doing it this way or that way. So the list is really kind of redundant. So when I do things, I generally do it this way just because it's more direct and it takes less time. So another thing we're going to talk about here, let's go ahead and, yeah, we'll just leave this up here for now. But when we're accessing list elements, you have to remember that lists are ordered and you can access each element with an index, just like a string. So like a string, indexes are zero-based. Most things are zero-based here. And you can use an expression in that index as long as it evaluates to an integer. It can't be a float like a 1.0. It's not the same as a 1. It has to be an integer. So if we want an example, we can show that car list of 1 is going to give us BMW because it's in the 0th place. If we put 1.0 here, what do you think is going to happen? Oops, yep, list indices must be integers or slices, not float. So we keep that in mind. So we put it back and it's happy again. So going on down, we find out another very important attribute of lists. Unlike strings, which are sequences, lists are mutable. That means that they can be changed without replacing the entire list. Remember in the past when we were dealing with strings, we talked about a string, and if you wanted to change it, you would have to reassign it. So you'd have my string equals, and then the string, whatever it is. And then if you're to do something to it, you'd have to reassign it there because the methods that act on strings aren't mutable. Because it's immutable, it's basically creating an entirely different string. Lists are different, they're mutable. So they can actually be changed in place. And we call that in-place modification. So to show you an example of this, we're going to go back here and we're going to print out our car list. And we're going to use this thing called append. And append is a method that works on a list object, and it allows you to add the thing that you put into the parentheses. So we should see our car list, which is Prius, BMW, and Lexus. And let's go ahead here and we're going to comment out all this code just because it's going to be getting in the way. And we're going to go ahead and we're going to append Camaro. So we're going to put Camaro in there. Append essentially adds one element onto the end of the list. And remember, list orders do matter. The order that you have here does matter. So it's going to append it at the 0, 1, 2, 3th place. So it's going to put it in the 3rd position. So, or well, not the 3rd, but it's going to put in the 3th, the index of 3. So 0, 1, 2, and 3. So it'll be in the 3rd, the 3th position, as we say. So if we go ahead and we run this, we'll see that indeed Camaro was added to the end. But the important thing to remember here is we're not saying car list equals car list.append. This is just using the car list.append. You run the method on it and it changes that object. So your object has changed here. So now we're going to go ahead and we're going to say the first element, the 0, 1th element. So the 1th element, the 0, 1, which would be BMW, we're going to set it to Nova, and then we're going to print it out. And you'll notice that we've changed BMW to Nova. And we haven't had to actually reassign car list to do that. So you see that things happen, what we call in-place modification. So you're not having to reassign car list to the result of something. So now we're going to move on. We're going to talk about adding an element to the end. So if you want to do that, well, let's first of all go in here and uncomment. Let's go over here. We'll just leave these as is. So we're going to print the length of the car list to see how long the car list is. And what we're going to do is we're going to come in here, and this is what is considered well, it's not the best way of adding elements. We'll show you some methods later on, but this is a method that actually, this isn't a method, but this is a means of adding an element to the end. And I'm not a fan of it. It works. And in general, you should avoid this type of actions. But what we're doing here is we're saying we're getting the length of it just to show you what the length is. Then after we get it, we're going to say we want to go to the car. We're going to take a slice of it, which is the last number, and then to the end of the string equals, and we put put the list with the element Corvette in it. This will allow us to add one to the end of our list, and then when we print it, it'll show that it actually happened. So we look in here, we see that we did indeed take Corvette and add it. But again, as we saw up here, the proper method to use for doing something like that is append, because this doesn't look as clean as something like this. So please avoid doing this, even though you can do that, okay? So keep that in mind. Also, we have a way of removing elements. And the way we remove elements is simply with this delete function. And it's not a method, it's a full out delete. So we can say delete car list of the first element. And when we do that, we'll see what happens. So we had 5 elements before. Now we've deleted the one in the first element, 0, 1. So we took out Nova. So Nova is now gone and Lexus is now in the first position, the 1th position. So as we were saying, because list operations modify in place, you have to be very careful. So if you have 2 variables that point to the same list, modifying one of them is going to modify the other. So to show you an example of this, we're going to come over here. We're going to say your cars equals car list. So in other words, this list that we just made, we're going to have your cars equal to cars list. They're both going to point at that. Then after we have them both pointing there, we're going to say remove the 0th element from your cars. And now let's look at both your cars and car list. And because they both point at the same object, you're going to find that doing this affects both of these. So when we hit play, we look at it and actually, hold on. Dun, 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 dun. Wait, so hold on. Oh, my mistake. I went ahead of myself. I was actually meaning to undo this over here and show that example. What we've done here, just to go to my faux pas, so what I've done here is I've said your cars is equal to car list, and I've used the slicing. That actually makes a copy of it. I'll explain that in just a minute. Let's get back to that. But going back to what I was saying a minute ago, we have to be careful. If we have two variables that point at the same list, if you modify one of them, it's going to modify both. So what we're doing up here is we're saying your cars is going to be equal to the car list. Then we're going to print the your cars just to show you that it looks just like the car list that we do right before it. And then we're going to delete the first object. So when we delete that first object, it's going to delete it from your cars, but because your cars is pointing at car list, it's going to delete it from both, and we print both of them just to show that. So when we hit print here, we see that indeed we had Prius, Lexus, Camaro, Corvette. We removed the first one, which is Prius. We just have Lexus, Camaro, and Corvette for car list. But also, for car list, it was because it was pointing at your cars. We removed it from your cars, but it's pointing to the same place, so it removed it for both of them there. So you have to be careful that when you use delete, and you have to remember that you're doing an in-place modification here. So that is going to affect anything that points to it. So that's a little bit tricky. Just keep that in mind. And then getting back to the example that I showed you a few minutes ago. So your cars, we're going to do something here. The way you get around that problem that we have up here is you make a copy of a list. And the way you make a copy of a list simply is you say your cars equals car list, but you use a slicing method here. In the slicing, we're just using a colon, which means take the whole thing. So we've essentially copied this object of car list. So then if we delete the first element, which at that point is going to be the Lexus, when we print out your cars, we're going to have just Camaro and Corvette. When we print the car list, we should have Lexus, Camaro, and Corvette. So let's see if that's true. And indeed, we have Camaro and Corvette left for your cars because we removed the 0th element. And we have Lexus, Camaro, and Corvette for car list, which does not point to the same thing as your cars. So keep that in mind. That's the one tricky part that you have to understand. And it's really important to keep in mind that these operations are in place because these are mutable objects. They're not immutable like the strings that we've dealt with in the past. So if you do that and you have different things that point to the same thing, you're going to get some funky results. So just keep this in mind. So if you have any questions, as always, send me an email, reach out. We can set up a Zoom chat if you like, and I can go through some of these concepts with you. Otherwise, I will see you in the next lesson. Take care, and I'll see you then. Bye.